mathematicians. Where did we leave things off yesterday? I think we left them off. I was confused about how to finish this level. We left it off anticlimactic. Anticlimactic. So, I guess we're just gonna finish off the level then, right? That's a goal. And what else are we gonna do? I guess we'll just keep playing the game. I gotta make stream shorter though. You know, I really do. I said that before. Oh, I gotta do a half-hour stream, and then like yesterday, I did an hour. But I gotta do work. You know, I gotta focus on my thesis and stuff. I spend a lot of time on YouTube. Let's be real, but I just don't want to stop. Okay. Let's try and get this done quick. So, let's see. Okay, Field Simp didn't do anything. That was the last one we did, right? Field Simp should... You're early this time. That's because I am late. So Field Simp... I thought it said something about clears denominators. Thought it said something about clearing denominators. Establish positivity first before using Field Simp. Okay. I don't know about this casting business. Oh, we do have we do have an error here. So why don't we go back here? Probably fix that. That could maybe be why Field Simp didn't do anything for us. Because we made a little boo-boo. Let's see now. Okay. Okay. That didn't quite help in the way that I was expecting exactly. Like, I want to manipulate this inequality to get the n up top. You know? What happens if I hit it with another Field Simp? Anything? No, it doesn't make any progress. It's funny because this is the most simple like algebraic manipulation, right? It's like put everything over 1, you know? So there should be some way to do this. I think Linarith failed me before, right? What was the command? There's a command that would like search through equalities or inequalities and just try and zip everything up, right? I think we did that last time. Oh, I think that was bound. Hello, Kostaka Corey. Maybe bound will search through. Okay, that did nothing. Maybe if I go back to here, actually. Merry Christmas to you too. Merry Christaps and a happy new beard. Oh, Linarith hypotheses. I see. Okay, probably I should have read more here. Arithmetic with inequalities. Might find Linarith helpful. Yeah. Okay. Okay, so maybe if I do a Linarith and I feed it some of these hypotheses, like A2, HN. No, didn't like that. What about just an A2? Well, it didn't seem to have an effect. I gotta go change this broken one now. What am I doing? I'm playing the real analysis game. All you want for Christmas is to understand the proof of Perron for Frobenius theorem. I remember doing that, I think, in a spectral graph theory course. I remember also being confused by it, though. Yeah, real square matrix with positive entries has a unique eigenvalue of largest magnitude and is real. Really, would we have used this? I guess. But I mean, we have a much stronger thing in spectral graph theory, right? It's like positive semi-definite matrix. Yeah. Positive, let positive and non-negative describe matrices of positive real numbers elements. Okay. Yeah, so I guess whatever. I guess this is what we want. Yeah. Would be much nicer to just explicitly invoke arithmetic properties of division. Yes, I agree. Sire, there's an error on the title. What? On the title? On the title? Oh, I see. Sequen messes. Thanks. Fixed. Okay. Yeah, what if we just try rewriting with A2 or Linarith A2? No. Linarith HN? Oh, I gotta. No, didn't like that. Yeah, this is really frustrating, to be honest. This is really frustrating. Like, I want to prove things about groups. The problem with ChatGPT is ChatGPT is probably not jacked into the real analysis game in particular, right? I could probably use Jeopardy to get it to come up with some lean code, but I'm not allowed to use all of the tactics, right? In lean, it only unlocks certain ones at a time. So add as many inequality hypotheses to your game board as you need, and then Linarith on them. Yeah, what if I try doing a Linarith with like every single possible, I just dump every one of them in there. Or Linarith. Let's do A1. Let's do HN. Let's do A2. Let's dump them all in. and see what happens. Failed to find a contradiction? I needed a contradiction? What do you mean a contradiction? I'm not looking for a contradiction. Does it give more hints in left panel? I mean, let's read it from the top, I guess. We want to prove this sequence converges to 0 as n approaches infinity. For every epsilon greater than 0, there exists an n. Yeah. Definition. Step 1. Let's just see if we did the steps in the order suggested. We want epsilon to be bigger than 0. Yeah. So... Therefore, this... Taking reciprocals... See... yeah, there's these confusing things where it says something like taking reciprocals and flipping the identity this. And it's like... Yeah. But that's the natural language explanation. How does one make lean do that? How does one make lean do that? Okay, and then there's these statements. So, yeah. Oh, God. I don't know why it also makes me jump like that. Sometimes I accidentally click on something or something. Okay. Implementation challenges. Cross-multiplying fractions. Our key step is showing this. In paper mathematics, we'd simply cross-multiply, but lean is very careful about division by 0. So we can't just cross-multiply willy-nilly. We want to go from that to that, but this is only valid if n is bigger than 0. Oh, do we have an n bigger than 0 somewhere? Well, I guess n is a natural number. And I don't know if natural numbers... Is 0 included in natural numbers in lean? Perhaps that is part of what we need. Is we need a statement that n is bigger than 0. So maybe... What if we tried something like a have n bigger than 0 by linarith? Something like that. Yeah, what's the right way to write it? Maybe this comes first and then by linarith. Let me go back here. Didn't like that. I mean, I'm probably doing something dumb. Oh, I guess I need to give it a name, right? Where's the other cases where I've used a have? Okay, well, have h1. Yeah, do I need to give this a name? Have... I probably need to name this, right? And here I don't need to use a by, I guess. Maybe that's part of the problem. Yeah, that's true, Rod. Maybe I could do it there. Let me go back a level. Okay, what's the right syntax for giving it a name, though? Okay, I give it a name and then I put a colon. So have, I don't know, what's a hypothesis name I don't have yet? Just a plain old H, I guess. Okay, well, nothing happened best because I have earlier errors. So let me go retry here. Okay, it wasn't happy with that. Hmm. Didn't like that. I don't know why. Or you can do have the type. Then it'll have default name. Okay. Oh, I need to use a buy. But then in when I looked at this other one, it wasn't. Oh, there is a buy here. Okay. Let me use a buy. Buy. Well, I want to. Let me retry. No, still not happy. Yeah, maybe I do need to go prove it earlier. When n is introduced or something. I don't know. Yeah, sometimes I'm excited about lean as the future of mathematics, and then I'm doing this. um, yeah, yeah. I mean, maybe it's just me. Maybe I'm just slow. Maybe I'm just slow. I mean, it's also weird. I haven't used exact modcast, which is being introduced. Um, that's a hint that maybe there's something else I need to be thinking about. Yeah, okay, but either way, I'm pretty sure I need that n is bigger than 0, right? But I mean, it shouldn't matter. I should be able to prove it now just as well, right? It's like, would it be? Oh, I see. No, because yeah, when I introduce n, I see. Hang on. So let me. Uh, and this is something that's set around the exact modcast. Where's that discussion here? It's weird because the definition of an doesn't even make sense for n equals 0. Yeah, so it should, yeah, so I guess the indexing should start at 1 anyways, yeah. 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 I don't know. Yeah. But then how does one prove this like immediately obvious thing? Uh, yeah, but the exact modcast is just about type matching, so that's not really a thing. But maybe I want to show n is a real number is bigger than 1. Okay, right. Maybe it's something here. Maybe it's something like this is bigger than 0 in what, /r maybe? Does that do it? Nice. And then maybe I'll need an exact modcast in there or something. Okay, let's just see. Well, it doesn't like it, but I'm also annoyed by this fact. Sometimes when I put in an error thing, it doesn't immediately let me retry the thing I just put in. You know what I mean? No, that failed as well, but oh no, hey, wait, what happened to the old version? Or the new version I just put in? Yeah, no, it didn't like that either. You mean it does make sense that in that lean puts a garbage value in such cases so that writing expressions isn't terrible? I'm not sure what you mean. The initial assumption HN they give you literally assumes... Wait, what? What? HN assumes you can divide by 0? What are you talking about? Okay, you proved H0 that epsilon is greater than 0. I mean, we already have that in our assumptions. Oh, you're proving that 1 over epsilon is greater than 0. Okay. So, okay, why don't we try that? Have H naught. Have H naught 1 over epsilon. Have H naught 1 over epsilon greater than 0 by Linareth, maybe? Didn't like that. Yeah, let me try it back here though. Yeah. HN says for every n there exists an such that an is equal to 1 over n, including... But where are you getting that it includes 0? Is 0 a natural number in lean? I mean, that's kind of the question, right? That's sort of the question that we're... How do we check types in lean? There's a way to do type checking. What is it? We can write something like check 0, right? Oh, it says starting at 0? Starting at 0. Okay. Huh. And 1 over 0 is equal to 0? Really? Uh... What? That's terrible, though. Why is that? Why? Why would they do that? I mean, in the sidebar, isn't there just here a lengthy discussion about how Lean is very careful to not divide by 0? And that's why we need to use this field simp tactic? Eval 1 over 0? Let's see. Oh, this is taking forever to start. This is so you don't have to provide a proof while dividing two numbers? I don't understand. I don't understand. Mary, you guys keep spelling Kristaps wrong. You guys keep spelling Kristaps wrong. Oh, man, I feel like, I don't know, maybe these lean streams are, I don't know, they've been slow lately. Maybe I should abandon this project. I don't know. Is it entertaining for you guys? I don't know. Is it maybe it's entertaining for you guys. Closed unexpectedly. Okay. Take another shot at it. No, where do I? Let's go back to my channel. I see. So there's a deep error in my proof, I suppose. That would explain why Linarith isn't working. I was just checking how many people are watching right now. But then, I mean, this is the assumption I was given. Like, I was given this assumption to work with. So, ugh. I've been naughty like a prime. So zeroness is just delegated to when we cross multiply. You think lean? Yeah. But if the hypothesis I have is false, then the whole real analysis game is busted, right? Or at least this level. Division you'd want would take two numbers and a proof that b is not equal to 0 and return a over b. But it would be terrible to use in practice. I still don't quite get it, but don't worry about me. Lean is sort of like the cool grandchild of Principia. This is true. It's also the holidays, which should be more or less viewers. Probably more viewers. Okay, so it looks like I also don't have Lean installed properly. It would be better to have a hypothesis that says for all n greater than 0, but it will make working with that hypothesis even harder. Why? Why would that be harder? Can't you assume a non-zero natural number, then input it for n? I mean, we could still prove that n is greater than 0 by using these other things, right? So what could we do? We have epsilon greater than 0. So I could prove that 1 over epsilon is... I mean, I should be able to prove that 1 over epsilon is greater than 0 from A1. And I would have thought that I could just hit it with a Linarith, right? But I guess not. I guess not. Like, why won't this work? There is a lean online which supports. Oh yeah, I guess I could try lean online. Lean online. Lean for web. Division is too complicated for Linarith. Linarith is for linear equations. Okay, but then how am I supposed to solve this problem? With a norm num? By a norm num A1. Interesting. I would not thought to have done that. By a norm num on A1. I guess that makes sense. What? It looks very weird. It's probably because I have to go back further and change my first falsehood that my first failed attempt here. Okay, that is progress. And then we have H1, which is that n is bigger than 0. Now, can this be done with a Linarith? Because we're just chaining together some inequalities? No. No. We could rewrite, though. We could do like a rewrite. We could do like a rewrite using H naught. Yeah. Possibly. Oh. Or a simp, maybe. I don't think... Do we have the simp tactic? We haven't unlocked simps yet. We're not hot enough. Frankly, you don't understand when to use norm num, field simp, ring NF, so you usually use all and see what happens. Yeah, I see. But you need to add more hypotheses to work with Linarith. I see. Right. Okay, so I could get... Let's see. So if I tell it to do Linarith with H0 and HN. No, I didn't like that either. Yeah. I don't know. Well, that's I think that's going to do it for today's anticlimactic episode. We didn't even manage to get through this. Maybe we'll try again tomorrow. But I'm going to go proof things on paper. I have field simp. Can I... What, you think I should just hit it with a field simp? Didn't make any progress on the goal. Yeah, I don't know. I don't know. That's where I'm gonna leave it. We'll see what happens tomorrow. Uh, I'm gonna go try and prove some things about equivariant sheaves now. That's what I'm gonna do. So, QED, sort of.